Alright, for this question, Batman, who has a mass of 120 kilograms, is holding on to a rope, and it gives us the length of the rope, and the other end is tied to a tree limb above. He's able to get in motion somehow, eventually getting into swing enough so he can reach a ledge when the rope makes an angle of 94.4 with the vertical. So that is this internal angle up here. Mine obviously is an acute angle, and this one's supposed to be a little bit larger than 90 degrees, so it's not drawn to scale by any means, but you'll get the idea. Alright, gravity is 9.8. The question's asking how much work is done against the force of gravity in this maneuver. Alright, so work done against gravity. So we're going to do work is equal to a change in energy. And obviously, as Batman's moving from the lower ledge to the upper ledge, the energy that's changing here is his gravitational potential energy. And most specifically, what's changing is not his mass and not gravity. What is changing is the height, delta H. So to figure out this change in height from the lower level to the upper level, that is going to correspond with, let's see how to draw it. That's this change in height here. That corresponds with the, how to say this height here. These are both the same delta H's. Okay? So the trick to play here is to use the rope itself. And the way we're going to find this change in height is we're going to use the length of the rope, and we're going to use this, because if we do a dotted line or a dashed line across here, then we can see that this vertical piece, if I can subtract that vertical piece from the length of the rope, that will give me the delta H, the difference in height. Alright, so this makes a little triangle. And if we're using our trig identities, then for our triangle here, this distance is going to be equal to the length L times the cosine of our angle. And my change in height, why did I just randomly, let's get rid of that. My change in height delta H, so you can visually see it, is going to be equal to the difference between the length of the rope and that vertical piece of the rope, which we said was L cosine theta. So if we merge all this together, we'll get our equation. The work done is equal to mass times gravity, and in place of delta H, what we're putting in is L minus L cosine theta. From there, we just plug in our numbers, and my numbers, I would have 120 times 9.8 My value for L was 8.34 minus 8.34 cosine of my angle, and my angle is 94.4. Alright, so if I put that in the calculator, what I shall get is 10,560. And that is in joules. That's our answer.